On Tuesday night, a small stream gauge near Buchanan, West Virginia, did something it had not done in roughly 80 years of record keeping. Sand run rose more than 8 feet in under 5 hours, cresting above 10.6 feet and shattering a flood. Record that had stood since 1985, the year of flood in that same county. Killed 47 people. This was not a hurricane. There was no tropical system anywhere near West Virginia that night. It was the direct, predictable byproduct of a massive heat dome breaking down at its edges, exactly the way meteorologists said it would, dumping up to 7 inches of rain in about 6 hours, and forcing the governor to declare a state of emergency across all 55 counties in the state. And here is the part that should actually concern you. That was not an isolated freak event. It was at least the third time this exact pattern has repeated itself across the United States since late June, and scientists are now watching a new heat dome build over the central United States that meteorologists are calling, without exaggeration, the strongest one currently found anywhere on the planet. If the pattern holds, and so far this summer it has held every single time, the breakdown of that heat dome is very likely to trigger another serious, severe weather outbreak within days. This is the story of what scientists are actually tracking heading into this weekend, why the risk of a post-heat storm outbreak is not being overstated, and what the data from 3 previous rounds of this exact pattern already tells us about what is coming. No hype, no exaggeration, just what actually happened and what the numbers behind it mean. Drop a comment and tell me if you are anywhere from the plains to the mid-Atlantic, and whether you have already felt this summer's heat domes yourself. I read every one of these. If you want grounded weather coverage instead of panic headlines, subscribe. It is free, and a like helps this reach people who need to see this before the next round hits. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why a heat dome breaking down produces dangerous storms rather than simply cooling things off, you have to understand what a heat dome actually is. It is a towering, slow-moving area of high pressure that traps hot air underneath it, suppressing clouds and rainfall directly in its core, which is why the middle of a heat dome tends to be brutally hot and completely dry. But heat does not just sit there quietly at the edges of that dome. Along its northern and eastern flanks, where the hot, trapped air meets cooler air in a stronger jet stream, meteorologists get what they call a ring of fire pattern, clusters of thunderstorms that repeatedly fire along the boundary of the high-pressure system, riding the jet stream from one region to the next, because the atmosphere in that zone is loaded with extreme heat and unusually high moisture. When those storm clusters do organize, they tend to do so explosively, producing what meteorologists call derechos, long-lived, fast-moving complexes of thunderstorms capable of damaging straight-line winds across hundreds of miles, along with training thunderstorms that repeatedly dump rain over the same towns for hours at a time. This exact mechanism has already played out 3 separate times this summer, and each time it has produced genuinely historic results. In late June and early July, a slow-moving heat dome settled over the East Coast, driving heat indices into the upper 90s and low 100s across a corridor stretching from Chicago to Boston, and toppling temperature records as it went. Just as meteorologists predicted, the breakdown of that dome around the 4th of July weekend triggered days of severe storms and flash flooding stretching from the Midwest into the Northeast, exactly the kind of transition AccuWeather senior meteorologists had specifically warned would be marked by powerful storms, lightning, and rounds of torrential rain. Weeks later, a second heat dome settled over the northern Rockies, pushing temperatures in Montana to 115 degrees, a level so extreme that numerous weather stations there recorded their highest temperatures since record-keeping began, according to NASA's own Earth observation program. That heat dome, too, eventually broke down along its eastern edge, contributing to the same kind of severe weather transition scientists had already documented once that summer. Then came this past week, arguably the most dramatic example yet. As a third heat dome shifted position, a slow-moving cold front dragged severe thunderstorms across Tennessee, Kentucky, Ohio, and eventually West Virginia, producing the flash flooding that broke the 80-year-old sand run record. Flooding had actually begun days earlier, on July 18th, when severe thunderstorms first dumped heavy rain across Barber County, damaging infrastructure well before the worst of the flooding arrived. By Tuesday, July 21st, some areas of north-central West Virginia had recorded as much as 7 inches of rain in roughly 6 hours, overwhelming creeks and drainage systems in a matter of hours, and closing Interstate 79 in multiple locations, including exits near Jane Lew and Weston. Confirmed tornadoes touched down in Ohio, Kentucky, and New Jersey as the same storm system swept toward the East Coast. Roughly 110,000 people lost power across the affected region. West Virginia's governor deployed 100 National Guard members to the hardest hit areas immediately, with 200 more arriving within a day. According to CNN's own tracking of flash flood emergencies, the country had already logged 15 separate flash flood emergencies in the 2 weeks before this one, including a flash flood and a wildfire burn scar in southern Utah that killed a fire captain, his wife, and their 3 children, a 1 in 1,000 year rainfall event in Missouri, and flooding in Texas, severe enough that campers had to be rescued directly off cabin rooftops. None of these were isolated coincidences. Each one traces back to the same underlying setup, an atmosphere loaded with more heat and more available moisture than it used to hold, releasing that energy explosively once a heat dome's grip finally breaks. Which brings us to right now. Meteorologists say a new heat dome is set to strengthen into what is being described, without hedging, as the most powerful one currently found anywhere on the planet, developing over the Intermountain West and plains, and expected to send temperatures surging past 110 degrees across a corridor stretching from the Dakotas down through Texas, with the core of the most unusual heat settling in over the plains and Rockies through much of the coming week. Meteorologist Ben Knoll, who has tracked each of the summer's heat domes for the Washington Post, described this one specifically as poised to tower over the Rockies and plains by Saturday, threatening to break yet more temperature records in a summer that has already broken an unusually high number of them. This is not simply a repeat of the earlier heat domes in strength alone. It is arriving while the atmosphere across the eastern half of the country is still unusually loaded with tropical moisture, since Tropical Storm Bertha made landfall along the Gulf Coast this week, and its remnant moisture is now interacting with a separate, stalled frontal boundary sitting over the southern mid-Atlantic and the Carolinas. Forecasters at the Weather Prediction Center have already placed a moderate risk of excessive rainfall over portions of the southeastern United States for the coming days, warning that some areas could see up to a month's worth of rainfall in a single multi-day stretch as that moisture interacts with the stalled front, independent of whatever happens when the new heat dome itself eventually breaks down. It is worth being precise about what scientists are and are not claiming here. Nobody is predicting the exact city, the exact hour, or the exact magnitude of the next severe weather outbreak. And meteorologists are always careful to note that setups like this one can be genuinely difficult to forecast with precision more than a few hours out, since storms in these patterns can fire, collapse, reorganize, and fire again in ways that resist a clean, simple prediction. What is not being overstated, based on the data from 3 consecutive repeats of this exact pattern already this summer, is the underlying mechanism itself. A heat dome this strong, sitting beside this much available moisture, has already shown this season that its eventual breakdown reliably produces severe, sometimes record-breaking weather along its edges, not as a rare fluke, but as the expected physically predictable outcome of exactly this kind of atmospheric setup. Climate scientists tracking this broader pattern point to a specific, measurable reason why these events keep breaking records, rather than simply repeating past ones. For every 1 degree Fahrenheit the atmosphere warms, it becomes capable of holding about 4% more water vapor. And Climate Central has calculated that the United States has warmed by nearly 3 degrees on average since 1970, a warming trend that translates directly into meaningfully more water vapor available to fuel exactly the kind of explosive downpours that broke the sand run record this week. Warmer oceans compound the same effect, feeding additional moisture into the atmosphere that eventually gets wrung out over land once a system like a heat dome finally breaks down. None of this means every heat dome will produce a disaster on the scale of this week's West Virginia flooding. It means the ceiling on how much rain a breakdown like this one can produce in a short window has been quietly climbing for decades, which is exactly why meteorologists are treating this recurring pattern as a genuine escalating risk rather than routine summer weather. It is also worth noting that this pattern has not been limited to the United States this year. Europe was hit by record-breaking heat events of its own back in May and June, part of the same broader summer of the heat dome that meteorologists have been tracking across the northern hemisphere, even though the specific storm outbreak risk discussed here is centered on the United States. So what does this actually mean for you, especially if you live anywhere near the path of this new heat dome or the moisture feeding into it from the east? The practical lesson from 3 repeats of this pattern already this summer is that the danger from an extreme heat dome does not end once temperatures finally start to fall. In some ways, the more dangerous phase begins right when the heat breaks, since that is precisely the moment this summer's data shows severe storms, flash flooding, and even tornadoes are most likely to erupt along its retreating edge. If you live anywhere from the plains through the mid-Atlantic and Carolinas in the coming days, the practical takeaway is to treat the end of this heat wave as its own end, not simply as relief after the fact, and to have a flash flood plan in place before the storms arrive rather than after water is already rising. Since this week's West Virginia flooding, like the Texas and Missouri events, Before it, gave communities only a matter of hours between the first heavy rain and record-breaking, life-threatening water levels. Knowing your specific flood risk in advance, whether you live near a small creek like Sand, one that can rise 8 feet in under 5 hours, or in a low-lying urban area with aging drainage infrastructure, matters far more during a setup like this one than any general awareness that a heat wave happens to be ending somewhere nearby. The honest, grounded summary is this. A heat dome breaking down at its edges has now triggered severe, sometimes record-breaking storm outbreaks at least 3 separate times already this summer, most recently this week in West Virginia, where a stream gauge broke. An 80-year-old flood record enforced a statewide emergency declaration. Scientists are now tracking a new heat dome, described as the strongest currently found anywhere on the planet, building over the central United States and expected to push temperatures past 110 degrees through the coming week, arriving at the same time that lingering tropical moisture from Bertha is already fueling a separate excessive rainfall risk across the southeast. Based on the pattern already established 3 times this season, the eventual breakdown of this new heat dome carries a real, physically grounded risk of producing another severe weather outbreak along its edges, which is exactly why meteorologists are describing this risk as understated rather than exaggerated. We are going to keep tracking this as it develops, sourced the same way we did today, straight from the Storm Prediction Center, the Weather Prediction Center, NASA's Earth Observation Program, and the meteorologists actually forecasting this pattern, not recycled headlines. Subscribe so you do not miss the moment this heat dome starts to break down, because based on what has happened 3 times already this summer, the transition is very likely to matter more than the heat wave itself. And leave that comment below. Tell me where you are watching from, and whether your area has already seen a flash flood emergency this summer. Because behind every one of these numbers is a family in Buchanan watching a creek they have known their entire lives rise past every level they thought was even possible. A National Guard member spending his week wading through someone else's flooded living room instead of his own home in an atmosphere that is quietly holding more water than it used to, waiting for the next heat dome to break so it can let that water go all at once. 5,000 likes on this one. Let us go. See you in the next one.